Hello. In this video, we're going to go ahead and solve the equation using the quadratic formula. Our equation is negative 4x squared equals negative 12x plus 11. And I will go ahead and say a lot of people will just add the 12x and subtract the 11, and they will get negative 4x squared plus 12x minus 11 equals 0, and that works fine. But here's the thing, I don't like having a negative a or a negative leading coefficient here, so we would just divide by negative 1 at this point, and that would give us positive 4x squared minus 12x plus 11 equals 0. And here's the thing, we could go from here to this one originally by just adding the 4x squared to both sides. It just makes it easier. And we mathematicians are nothing if not, let's call it efficient instead of lazy, because, you know, lazy has such a negative connotation, and, you know, I'm okay with being lazy, but okay. Anyway, moving the 4x squared to the right, we have 0 on the left-hand side, and on the right-hand side, we have 4x squared minus 12x plus 11. Awesome. So this is now in the form of 0 equals ax squared plus bx plus c. Remember that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Anyway, the next thing we want to do is we want to go ahead and find the discriminant. And if you remember, the discriminant is just the b squared minus 4ac. So to do that, we need a, we need b, and we need c. We need to know what they are. So a is the number in front of x squared, which in this case is 4. B is the number in front of x, and in this case that's negative 12. And c, the constant term, is 11. Awesome. Then we just find the discriminant, b squared minus 4ac. Now b is negative 12, so it's negative 12 all squared, minus 4 times a, which is 4, times c, which is 11. And then you can just top this in if you want. Negative 12 squared is 144. Negative 4 times 4 is negative 16. Negative 16 times 11 is 176, negative 176. And then 144 minus 176, what is that, 32? Negative 32, I believe. Yes, negative 32. Okay, good deal. Now that we know that that is negative 32, I want you to take a moment here. Because the discriminant is negative, we're going to have the square root of a negative number. And remember, square roots of negative numbers give us imaginary numbers. In other words, non-real complex numbers. So we're going to have, for our answer, as 2 complex conjugates for our solutions. Okay. Alrighty, so let's see how. If we plug all of the stuff in, now negative b, since we already saw how that works on the previous one, negative b is the opposite of negative 12, which means positive 12, plus or minus the square root of the discriminant negative 32, all over 2 times a, and a is 4, so 2 times 4 is 8. And then we simplify. We have this negative inside the radical, so we bring the negative on the outside. So that's going to give us 12 plus or minus I root 32 all over 8. And then we just simplify the square root of 32. So off to the side, 32 is, say, 2 and 16. 16 is 4 and 4. So 4 is 2 and 2, and 4 is 2 and 2. And again, we're looking for pairs of primes. So here's a pair of 2's. Here's a pair of 2's. And I can't circle this 2 because there is not another 2 to go along with it. So we have a 2, 2, 2, 2. And that's a lot of 2, 2's. Anyway, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 16 times what's not circled is the 2. And that's what we should think of the 32 as. So this is going to give us 12 plus or minus I square root of 16 times 2 all over 8. And then just Square root of 16 will be 4. Square root of 2 is just the square root of 2. So this gives us 12 plus or minus 4i square root of 2 all over 8. And because this is now a complex number, we must have this in the form of a plus bi, which means we have to break this up into two separate radicals, or two separate fractions, sorry. So we have 12 over 8 plus or minus 4i root 2 all over 8. And then simplify. 12 over 8 simplified is 3 halves, plus or minus, and then 4 over 8 simplified is 1 over 2. So in other words, this 4 here becomes a 1, and the 8 becomes a 2. So we have I root 2 all over 2. And be careful, do not cancel these two. Do not cancel this 2 with this 2, because only radicals affect other radicals. Because this is a radical, this is not a radical, they don't affect each other. And there you go. This is your solution, or are technically your two solutions. Alrighty. Well, I believe that is it for this particular video. I will see you in the next one. Have fun.